Hello, class. This is Professor Judy Perry. I just a few minutes ago received confirmation that my confirmed Zoom account is now active, and so I am testing it out and I'm attempting to record my session here. At the moment, I don't have any students in my Zoom session, so what I'm going to do is share my screen and take a look at some of the solutions in the solution module and talk you through the kinds of things that I look for when I'm grading. If students end up joining this session while I'm here, then we can engage in real time, and I am happy to do so. Okay, so let's see if I can share my screen and record. Oops, let's see. All right, so I think I'm sharing the screen. Um, I'm actually going to let students know if anyone is available that they can join this confirm Zoom session. Um, so let me type that note. All right, if anyone joins, you'll be in. All right, so in the absence of students here, let me just see if I can talk you through some things I look for when I'm grading and see if that helps you as you're doing your assignments. For the most part, you're doing a great job with your assignments. You've got good logic and your programs are working. What you generally need to work on is your style. 20% of your points are for good style, 80% is for it working right. So I'm going to talk or walk through a couple of these solution files and tell you what's good style and what I'm looking for, and also just comment on some of the logic as well. Let's start with something more interesting like the laser cantina solution. I'm going to click here. Now what I do is I generally find a student who did an excellent job, and then I'll do a screen print of their solution and post it here. So you may notice that that one of your files is listed here. Okay, so in this one, the student got almost everything right. The only thing I would recommend is a quick change here. So let me start from the top and walk through. This was the Laser Cantina solution. We need IOStream namespace standard. I like to see this at the top of main. All your declarations appear here, your variable declarations and your constant declarations. Your variable, as a matter of good style, should be camel case. That means variable names start with lowercase, and if there's a second word in it, you move to uppercase. So notice it starts, the M in meal is lowercase and the C is uppercase. Same with tip amount, tax amount, total looks good. My only comment for style here is when you use a constant, the identifier should be all uppercase. That is an indication to all programmers when they're reading through code. If you see all uppercase, then you know that it's a constant and not a variable. All right, so tax rate should be all uppercase, tip rate should be all uppercase. But in this case, this student chose a good data type, either float or double would work here because you know that you need a decimal component, dollars and cents in this case, so you don't want to use integers. Cout statement to welcome the user. I like that there's a blank line before and after it. It separates logical blocks of code and it makes it easier to read, both for me as an instructor, but also for any programmer that might come in and look at your code. So this is good if you're in the workforce as well. It's not just for academic purposes. CN statement is used to accept data from the user for meal charge. We call this prompting the user. A cout statement prompts the user to input. A CN statement accepts the input. Now, this block of code is for all the calculations. And I like that. I like to see your input. I like to see your calculations. Then I like to see your output. So 3 assignment statements to take the meal charge multiplied by tax rate, tip rate, and then the total adds those 3 together. Again, tax rate and tip rate should be all caps. All right. And then we've got a series of cout statements. And we have a label, and then we have a dollar sign, and then we have meal charge. You don't have to have another cout statement here. It's perfectly fine. You could remove the semicolon, remove the cout, and then just have one cout statement each. All right, and then return 0. That looks like a good solution. Another solution would be to use IO manipulators and use set precision to and fixed. That would mean that your all of your dollars and cents would have 2 decimal places. Let me go to the next solution. Area of a cookie. All right, so I asked you to use a constant for pi, and pi is all capital. That's very good style. Um, Actually, let me back up and start from the top. There were some comments up here. I took out the student's name, but I left in that the description of this program, which is Lab 3A, area of a cookie. In this case, we've got not only IO stream, but IO manipulator, string, and CMath, because I want you to experiment with more libraries. So in this case, good data types were chosen. That's one thing I'm looking for, that you know which data type is appropriate for which variable. So student ID, either string or integer is good. Now I know the student ID is a number, but that number is never used in math. It's used as a description. So you often find this in databases and in other kinds of apps that an ID number could be an integer. If you wanted to make it a string, that is acceptable too. Cookie size is an integer. You're never going to have a decimal component there. Float or double for radius and area, good choices. String for name and cookie type, good choices. And I said to use a constant. A float is good for pi, and I said to use 3.14159. All right, here is the input to actually 3, 4 areas of input. All right, so it always comes in pairs, a cout to prompt the user and a get line or a cin to get the data. So prompt and get the name, prompt and get the ID. We need to use cin.get because it's in between a cin and a get line statement. And we prompt the user to enter the type of cookie. And we need to use getLine because there is a space in a couple of these, chocolate chip and oatmeal raisin. So you have to prepare for the event that the user might input a string that has a space in it that requires the use of getLine. Same with your full name. Full name has a space between the first and last name, so you must use getLine. Enter the size of the cookie, 6, 8, or 12. That's an integer, so we use cin. And now we do our calculations. So everything above here was input, right? We got our declarations first. Perfect. Have all of our input here. Now we do our math. 2 assignment statements. Good use of the power function. I wanted to see you use the power function. A little better would be to put a 2.0 here because it requires a float or a double. In this case, it's okay because it will change that from an integer to a float when it does the math. IO manipulators were used, fixed and set precision to 2, and the output is here. That all looks good. Notice also everything's lined up at the same level inside of main. This is showing up here only because when I look at it in Canvas, it wraps the text into the size of my window. All right. So if this were in Visual Studio, all this would line up. All right, good style, good logic. It works 100% there. Let's see what else we've got. Okay, so this one was a little more involved, the box office solution. And I wanted to see you use a lot of the skills and constructs that we just learned in the labs and also include what we know about data types from week 2. So we've got IO stream, string, and IO manipulators. Here are my declarations. Here is all my input. Here are my calculations. I'd like to see a blank space, a blank line between input and calculations, but in this case, I don't think I took any points off for it. But it clears things up for me to use blank lines to separate logical blocks of code, and in this case, separate this input from this math. And then here's all the output. All right, so let's walk through this. Movie name, that's a good descriptive name, starts with lowercase, as variable should, and data type is string. We have integers, adult ticket and child ticket. Good descriptive names. They're self-documenting because it tells me the purpose of that variable. Started with lowercase and went to uppercase. That's called camel case. That's good. Chose a double. Double for profit adult, profit child, gross profit, net profit, distributor fee. Great self-descriptive names or self-documenting names. Constants, very nice. I wanted to see the good use of constants. Constant, double, float or double would work here. Everything's uppercase for your constants, and you must assign a value at the same time you declare your constants. You have to give it a value, and that value will never change through the course of your program. It is constant, right? So assign 3 values here. And now in English, there is a typo here. Theater is usually spelled ER, not RE. I think that might be the British spelling. But as far as C++ goes, as long as you're consistent with what you with how you declare it, you're going to be fine. So notice it's declared this way here and it's used this way here, and all is well. I didn't take any points off for that. All right, we prompt the user, enter your film name. Because it's a string, we have to use getLine. Enter the number of adult tickets for this movie name that we just got from here. That's very user-friendly. I like to see that. And we use a CN to get the integer for the adult tickets. Prompt the user again, number of child tickets sold for the movie name, and CN to get that integer for child tickets, right? Again, I'd like to see a blank line here to separate input from calculations, but here we have a couple of blank lines and we set our precision and we start doing the math. So we have assignment statements, profit adult, profit child, gross profit, net profit, distributor fee. Notice how readable this is. Because this student used good descriptive variable names, it's very easy to understand what's happening in this math here, right? This is a good example of why you don't want to use, for example, XYZ as your variable names. C++ would allow that, but it would be really hard to decipher as you or me are reading through your code. So this is very readable. The profit for adults is equal to the price for adults times the number of adult tickets. All right, so we do all the math here, and now we're just doing our output, right? And we have our fixed and set precision up here. This is in place. It's implemented until there's some other change to the IO manipulators. So you can do it up here. You can do it right here above your cout statements. Either way is okay. I generally do it right here before I start my output. Good use of columns, right? We want everything to be left aligned in a column 30 characters long. Perfect use of your IO manipulators here. The first column is 30 characters long, and whatever is in this string here, in the first string, will be left aligned, and it will be in a column 30 characters wide. So even if this movie name : space is not 30 characters, it will fill in the rest of that column with blanks, all right? So movie name will be in the first column, and then we'll do movie name, and then we end the line. Adult tickets sold, same thing. Good use of alignment manipulators and column manipulators. All right, all this looks good. This student got full credit as well. And I think we might be done here. Do we have anything else? This was not for you. That was from a previous class. All right, so area of a cookie, box office solution. All right, so that's all I want to do for now. I'm testing out this technology. Let's see if I was able to actually record a session and then find a way for you to have access to it. Everyone, I hope you're home and staying safe and staying healthy. Reach out to me if I can be of any help or if you have any questions.